going in details that which kind of transmission line it is. We will just I will just tell you that how we calculate the mutual GMD and self GMD. Actually, by considering these two sides, I will consider this as one side, or I can say that I will consider this as a, you can consider it as a one phase, and this as a second phase. So for mutual GMD, I will consider the distances of all of both sides. For self GMD, as we calculated in the last lecture, I will just consider one side. So firstly, we are going for mutual GMD because mutual GMD I didn't explain before. So here, the given transmission line has two sides, X and Y. Okay, so the question is that we have to calculate the GMD. Okay, you can say that mutual GMD. Okay, so to find mutual GMD between two sides, we will not include the distances of self GMD. Okay, we cannot include. Actually, if I will show you in next slide, even if I include the distances of the self phase side, the answer will be the same. So firstly, I am not considering the distances of this side, and then you will find the mutual GMD because this is first one phase and this is another phase. We consider it like that because it is given there are two sides, side X and side Y. Now for mutual GMD, I am for mutual GMD, firstly we will find the distances, okay, from this phase to this phase, from this side to this side. So like just like the last time, we started from distances. So firstly, I have to explain this, that the distance from A to D is 30 feet, it's given. Okay, then I will go for distance from A to E. Okay, because I am finding mutual, not self. For self, I have to consider only this side, but I am going for mutual. So mutual means the between it is between two phases. It is between two sides. Distance between this side to this side. So firstly, for A, I will go A to D distance is 30 feet. It is given 30 feet, and then A to E distance. A to E is actually I am explaining here that how its distance is 36.05. So we know that the distance from this point to this point is 30 feet, and distance from this point to this point is 20 feet. As you know that it is in parallel. The distance from here to here is equal to the distance from here to here. So I will write is 20 feet here. It is perpendicular of triangle, and then I will just draw a triangle here. Then from the formula we just learned in our high school formula that the hypotenuse square, okay, I am writing to it is square, is equal to base square plus perpendicular square. Okay, so by removing square here, I will get under root here. So it is the same formula. Under root means 1 divided by 2. So actually this is the hypotenuse of triangle. So hypotenuse is equal to base square plus perpendicular square under the root. So this is the formula we are getting from geometry. As I told you before that we must know about geometries when we go for inductances. So do you have any problem in this? Do you know? Did you understand this? You can speak now.
Yes, I understand it.
So moving towards, okay, moving forward. So this is 30 square plus 20 square, it is 1300. Then 1300 under root is equal to 36.05. Even if you have a calculator, you can calculate it later or now, both are okay. So after that, this is distance I just found here. It is not given in the problem. Normally, it will not given in the problem. You have to find it, these distances. So now I'm going for distance, then the distance from A to D, and then distance from A to E. Then I will move towards B, the distance from B to D, the distance from B to E. Then I will move towards C, the distance from C to D, and the distance from C to E. Firstly, I have calculated it and then I will put it in formula. The formula I will explain to you. Yesterday I also explained, but I will explain again. So this is A to E distance. I just have found 36.05 feet. And then we move towards the second conductor B. The distance from B to D is also 36.05 because you will say it is also perpendicular, it is base, and it is hypotenuse. You can use the same geometric formula that hypotenuse square is equal to perpendicular is equal to base square plus perpendicular square. Okay, I'm clearing this triangle. So B to D is distance 36.05, and then I will go towards B to E distance, which is given 30 feet. I have written here. Then the distance from C to D distance. So we will again use that, we will again make a triangle and we'll calculate the distance. So this is the perpendicular of that triangle, which is 20 plus 20, 40. So I put here 40 square. This is the base of triangle, 30 square, perpendicular square plus base square under root. So I have calculated the distance from C to D. It is like that. So then we move towards, then we move forward, then it is 50 feet. If we will calculate it, it is I think 2500 something. Yes, 2500 square root will be equal to 50. You know that. C to E distance is similar because here perpendicular is 20 and base is 30. So same answer, 36.05 feet. So now mutual GMD. So now I have, for mutual GMD, I have told you that I will always consider the distance from one side or one face to another face. I will not consider the distances self-face distances. In case of self GMD, we are going towards the conductors of same side, the conductors of same face. Okay, so BC is equal to 36.05. Okay, so I have calculated all the distances A to D, A to E, B to D, B to E, C to D, C to E, and I have written here. We have only 6 distances. These are enough for calculating GMD. Okay, so mutual GMD will be equal to same. I have explained before in last lecture. If we have 6 distances, then we will put in power 1 divided by 6. If we have 5 distances, we will put 1 divided by 5 in power. So here we have 6 distances. So I have put 1 divided by 6 in power. So I will write all the distances. 30 feet multiplied by 36.05 feet multiplied by 36.05 feet multiplied by 30 feet, 50 feet multiplied by 36 point. It's not 5, okay? It's 36.05. It is written wrongly. It is wrong. So if I will multiply all these distances, I will get 213 of big figure, 213,459, like this, 977,106. And then I will, using calculator, if you will use calculator, then you will, in power 1 divided by 6, you will get 35.8 feet. This is the mutual GMD of this transmission line at this place, at this pole. You can say that this is the mutual GMD. Mutual means that it includes the GMD of all the conductors. Then we will move towards the self GMD. If you have any question in mutual GMD, you can ask now.
No, I understand it. Thank you.
Okay. So we move towards the second slide. So there is another way through which we can find the mutual GMD. It is just for understanding, okay? You can just remember this method. It's enough for you. I just want you to understand it. If I will calculate all the distances, all the 9 distances, actually we have 9 distances over here. A to D, A to E, A to B, A to C. Then B to A, B to D, B to E, B to C. Then C to D, C to E, and C to B. We have, if even I will calculate all the distances, Because sometimes if you got confused between sides, sometimes for example you don't know that I am on which side. Okay, you don't know this conductor is on my side, on side 1 or x, or on side y. You can also use this method. You can calculate all the distances, but you have to put power 1 divided by 9. This is 36.05. Okay, you have to put, because here are 9 distances, so you will get the same answer. So answer will be the same, even if you are getting confused that okay, which conductor is on side x, which conductor is on side y, or which conductor is on phase 1, which is on phase. For example, in diagram, if you get confused, so you can calculate all the distances and then put power 1 divided by 9. You will get the same answer as we got in last PPT, 35.8. It will be the same. So this is even if you get confused. If you are confident, then you can simple put these distances. It's enough for you. You are now we move towards the notes provided by your supervisor. So here you can see that she had calculated. She just included. She used the method 1, A to D, A to C, B to D, B to E, C to D, and she got 35.8. The same method. Okay, so it is our answer correctly matched with your notes. So now I'm moving towards the I would say next slide. Uh, there is another way. I already told you about this. Now we are going to calculate the self GMD of same conductors, same conductor geometry. Okay, okay. It is actually firstly you don't look at it. Okay, just forget it. Just move from here. For self GMD of x, I will just consider the conductors on side x or on phase x. I will not go for side y or phase y. I'm just staying on side x. So the first distance, just recall the lecture I had delivered before last week. You will remember that firstly we will calculate the, okay, I am opening that. Okay, you can just, by calculating self GMD, we were just considering the conductor 1 with self. It means its radius. So the radius given in your notes is 0.5 inches, 0.1 inches. It's given in your notes. Okay, so firstly I will go self distance, the same thing I have explained before. Okay, but I'm staying on side x because I have to calculate the self GMD, not total GMD, the self GMD here. This is the self GMD of side x. So firstly I will go towards the d distance a to a, or you can say that the self distance of a conductor, or you can just write daa. It's 0.1 inch, but as I am all the measurements I am taking in feet, so I have to convert this inches into feet. So I will just divide it by 12. So what is this 0.7788? Do you know this? 0.7788. What is this?
It's the e to the power of negative
Yes.
0.25.
Okay, now I know you understood it, right? So, okay, so here you can see that it's e negative power minus 1 divided by 4, because we have to consider the effective radius. Now I am telling you one more secret, that why we are considering the effective radius. You know that there is skin effect in transmission lines. If there is alternating current, the current doesn't flow on the 100% of conductor. It flows outside of outer side of part of conductor. That's why we always go for effective radius. We are not going for full radius. So we multiply it 0.7788. So now you understood that the current flows on only on 77% of transmission line area, because it is AC current. AC current always flow nearby borders. It is, we call it skin effect. It's due to the Faraday's law, you know that due to magnetic field and a lot of other things. So I'm not going in detail here. So its self radius is 0.1 inch. So we have to convert it in feet. So we just divide it by 12 and multiply by with e raised power minus 1 divided by 4. We'll get 0.0065 feet radius of this side. I don't know radius of this side. It looks big in diagram. Maybe it's 0.2. You have to calculate it. I will check it in next lecture that whether you have calculated right or wrong. It's your assignment that you have to calculate the, or you can send me assignment by WhatsApp that you have to calculate the distance of side X. Okay, I will move towards the G. Okay, this is the self distance. Then I will move towards the second distance, which is A to B. It is 20 feet given. Then A to C, this is 40 feet. Then B to B. Now I will move towards the same we have studied in last lecture. That it is because the radius of all these, effective radius of all these conductors is same because they have same radius. So 0.0065 feet. And then B to A distance. In self GMD, we also calculate B to A distance. So B to A is 20 feet, and then B to C is 20 feet, and then C to C, the same. It means the with self self distance is the effective radius, which is 0.0065 feet, and then again from C to A, which is 40 feet, and C to B is 20. So now the self GMD of X side is I have to multiply all these. There are 9 values, so I am putting in formula 1 divided by 9, 1 divided by n. So this is the formula of GMD, geometric mean distance, 1 divided by n. So there are 9 distances, so I have to put here 9. So you know that there are 3 radius here, effective radius 0.0065 multiplied by 0.0065. We have to multiply this one, we get its cube. We have to multiply this 40 with this one, we get square. We have 4 20 feet values, so that's why I directly put it 20 raised to power 4. I'm not writing it 20 multiplied by 20 multiplied by 20. I just put it here. So after multiplying this, you will use your calculator after the lecture, and you must verify all the answers I have written here. I will send you PPT, and if so 70.304, I will take 1 divided by 9 is the power. Its answer is 1.60, maybe 49 something. I have just found it like 1.605 feet. So if you compare it with the your professor also called it